we're going to use the formula that we have to find the number of elements in the intersection. We're given A has 10 elements in it, set B has 12, and if you combine them all together, there's 16. Now, look for a formula that you have that has all of these things in it. This one, number of elements in A, number of elements in B, the number in the union, and the number in the intersection. We have one. Let's write the formula. It goes like this. The number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersect B, right? That's the formula that we're going to use. And now let's just substitute the numbers in. So what do we know here? The number in the union is 16, so we'll put a 16 here. That's equal to, now the number in A, we're given that's 10, so we can put a 10 here, plus the number in B, and we're given that B has 12 elements in it, minus, and this is the one we're looking for, A intersect B. So a little bit of arithmetic here. How about 16 equals, 22, minus the number in A intersect B. Let's subtract this 22. So over here, 16 minus 22 is negative 6. Get that to right. Negative 6 equals, and 22 minus 22, that term is gone. And then we're left with negative the number of elements in A intersect B. And now multiplying both sides or dividing both sides by negative 1, we're going to get that there's 6 elements in A intersect B. Now, we're asked to find the number of elements in set S, and here's the information we're given. We know how many are in the union, 64. There's 11 in the intersection, and T itself has 58. So we're going to apply this formula over here that we used last time. We're in the formula we used last time. We had sets A, right, A and B, and now we have S and T. So let's rewrite the formula in terms of S's and T's. So it says the number in the intersection, the union, S union T, that's the number in S plus the number in T, so add up the individual numbers, and then subtract the number in, let's actually get this here, the number in the intersection. So filling in these numbers, the number in S union T is 64, right? The number in S union T, that's up here, that's 64. Now that's going to equal the number in S, we don't know, that's unknown, we're looking for that, plus the number in T, but we're given that T has 58 elements in it. So there's going to be a 58 here, minus the number in the intersection, right? The intersection, and we're told that the intersection has 11 elements. All right, so let's see what we'll get here. 64 is equal to the number of elements in S plus, how about a 47? And then why don't we subtract 47 from each side? And doing so will give us, now, 64 minus 47 is a 17, and that's equal to the number of elements in S. Let's kind of imagine what's going on here. We've got a set C, and the number of elements in this set here is also equal to the number of elements in C intersect T. So what can we conclude about C and T in this case? Well, let's draw some pictures here just to get an idea of what could happen. What if we drew it like this? Here's C and here's T. Now, there could be numbers out here, meaning that there would be more numbers in the intersection than just C, right? So there'd be 2 in C, but there's more. There's a lot of numbers in C, but just 2 in the intersection. So we can't have this situation right here. That's not going to work. Let's try to draw something else here. What if we drew like this? Here's C and here's T. Now, here's some elements in C. Here's, you see these here? These are in the intersection of C and T, right? That's here, right? Because when you're in here, you're in C and T. But there's so many in here, but there's more out here. So the number in C, all of these together, is bigger than the number just in the intersection. So this isn't going to work. Let's try switching those. What if we wrote this? Here's T and here's C. And now let's put some numbers in C and T. Now, in this case, the number in C is, well, in this case I drew 3. But what about the intersection? The intersection of T and C is right exactly there. So that would also be 3. So it looks like out of all these things, these possible pictures we could draw, the one that makes it work is this one right here. So what we're going to conclude here is that if this is true, then it must be that C is a subset of T.